Okay, so let's finish off today with example 4b. It says, use the property that opposite sides of a parallelogram are equal to prove that a rectangle with all angles 90 degrees has diagonals of equal length. So remember, rectangle is a special case of a parallelogram where all the corner angles are 90 degrees, and we want to show that the diagonals of this rectangle have the same distance, have the same length. So let's first start by drawing a diagram. So bring out your trusty ruler so you can get those beautiful straight lines. Let me zoom in a bit. So part B, let's draw our rectangle. Okay, that's my rectangle. I'm going to label it A, B, C, D. I know it's rectangle because all four corners have 90 degrees. And since a rectangle is a special case of a parallelogram, we have that opposite sides have the same length, and that we have the opposite sides are parallel as well, which I'm going to indicate using arrows. Okay, so let A, B, C, D be a rectangle. What is our goal? Well, we want to prove that the diagonals are equal in length. What does it mean specifically? Well, if we drew in our diagonals, which are A to D and B to C, so bring out your ruler, draw that beautiful straight line. And from B to, oops, too much. And then from B to C. Is that gonna work? There we go. So we want to show that AD, that diagonal, has the same length as BC. So that's our goal. So let's do some thinking. How are we going to get to our goal? Again, the most easiest way is to use congruent triangles. So see if you can spot any triangles. If we can prove congruent triangles, then because of congruence, the length of the sides are the same automatically. So we're thinking, let's look for, so we need congruent triangles. Specifically, if we can show that triangle ADC is congruent to triangle BCD, right? So ADC is the blue triangle versus BCD is the yellow triangle. If I can prove that these two triangles are congruent, then AD is the same length as BC because congruence. Yeah, so that's our goal. So let's do it. So how do we show congruent triangles? So let's consider triangle ADC and triangle BCD. Well, okay, how are we going to do it? Can we do, well, we can't do side, side, side because we don't know the third side information, so that's gone. We do have two sides that we know because of the 1 dash and 2 dash. And if we use the angle as well, the 90-degree angle, then we've got side, angle, side. So that would be our plan of attack, to show congruence using side, angle, side. Okay, so for starters, we know that AC is the same as BD, right? Because it's a rectangle. Rectangle meaning it's a special case of a parallelogram. Parallelogram meaning that opposite sides have equal distance. So AC equals BD, since it's a parallelogram and it's given to us. What else do we know? We also know that the side CD is common. CD is common side. And lastly, we know the 90-degree angle, angle ACD, is the same as angle BDC. Match up your vertices. And in this case it's 90 degrees because we're told it's a rectangle. Side angle side, there we go. Therefore congruent triangles. So therefore triangle ADC, triangle, oh yes, no, it is right. Triangle ADC is congruent to triangle BCD because of side angle side. Because of congruence, therefore my two sides AD is the same as BC. So therefore the diagonals have equal length. And we've reached our goal. So let's finish off with a sentence of what we wanted to prove, which is therefore rectangles, which is a special case of a parallelogram, have diagonals of equal length.